Welcome to Learning Knockout.JS, brought to you by Pact Publishing. My name is Robert Gott. I've been a software developer since 1998 and have spent much of my career as an instructor and mentor. I'm really excited to be a part of this video course because Knockout.JS is a tool that I use daily, and I firmly believe that you'll love it as much as I do. In this video, we're going to take a look at the topics covered in this course, and we'll examine some obstacles to building data-driven websites. Then we'll highlight some features used in Knockout.JS, and lastly, we'll preview the sample project that we'll be building throughout this course. As web developers, we've all been faced with the task of interacting with data through HTML. Whether it's simply displaying a value retrieved from a database or posting a form for processing, at some point many of our user interfaces will need to interact with the server. With the introduction of Ajax, much of the work we perform to build web-based applications takes place on the client side. Once our applications become non-trivial, though, we often experience a lot of bloated and unmanageable code intermingled in our HTML. That's where Knockout.JS comes in. Knockout.JS, or just Knockout, is a client-side data binding library that greatly simplifies the task of building data-aware web user interfaces. What used to take a lot of effort now only takes a relatively small amount of script and a minimal amount of markup. By using simple attributes in your HTML, you can establish a connection between UI elements and your JavaScript business objects. The connection isn't just one way either. Once you have an association between a UI element and your business object, changes you make to the business objects are reflected in the UI, and changes in the UI are propagated to the underlying business objects. This two-way data binding is where Knockout.JS really shines. To help demonstrate the many great features of Knockout.JS, we're going to build a media library application throughout this course. If you're like me, you probably have a lot of friends who borrow your books and movies. Most of the time my things are returned, but there's an untold number of items I'll probably never see again. My problem is that I forget who borrowed my things, so I never remember to ask for them to be returned. So what we're going to do throughout this video course is build a media tracking application so that we can keep an inventory of our media assets and record who may have borrowed them. We'll build data entry screens for our catalog of media assets, as well as a screen to manage our contacts. Then we'll build a dashboard that will allow us to see what we have in the inventory, what's been borrowed and by whom, and when our items are supposed to be returned. Along the way, we'll explore the architectural challenges of building such an application and how the design patterns encouraged by Knockout can help us. In the first section of this course, we're going to explore the two software design patterns on which Knockout.JS is built: the Model-View-ViewModel pattern, or MVVM, and the observer pattern. We'll also cover the JavaScript module pattern, as this will be used throughout this course. In the second section, we'll begin building our sample project and introduce you to one-way data binding, where you will use Knockout to display data on the page. Two-way data binding is covered in the third section, and we'll start adding data entry forms to our sample project. In section 4, we'll tackle the concept of data context. This can be tricky to understand at first, but it's central to the MVVM pattern in Knockout.JS. By the end of section 4, though, you'll be a pro. Section 5 walks you through computed observables. This is a powerful feature of Knockout.JS that I think you will really enjoy. With the basics firmly in hand, Section 6 will examine what it takes to extend Knockout.JS for a variety of scenarios. We'll create custom functions, extenders, and custom bindings that will really make your application shine. To end this course, we will spend Section 7 looking at some of the advanced things that you can do with Knockout.JS. This section is to let you know what's possible and how to take what you've learned to the next level. To get the most out of this video course, you will need to have a basic understanding of HTML and JavaScript. You will also need a text editor, or preferably an HTML and script IDE like Microsoft's Visual Studio. You will also need to have installed a modern browser. The most recent versions of Internet Explorer or Google Chrome will do nicely, and of course access to the Internet. I hope that you're as excited as I am. Knockout.JS is truly a game changer for web development and really makes programming data-driven applications a lot of fun. So let's get started. In this section, we're going to look at some software design patterns that are used by Knockout.JS, namely the Model-View-ViewModel and observer design patterns. We'll also look at some JavaScript-related design patterns that will set the stage for the code examples and the sample project. Even if you've only been developing for a short time, you've probably heard of software design patterns. But what are they? Well, design patterns are essentially time-tested solutions to recurring design problems. Most design patterns center around code reuse and making applications more maintainable and manageable. Some of the first design patterns were published in 1995 in the book Design Patterns: Elements of Reusable Object-Oriented Software. Since that time, several more design patterns have emerged. Then in 2005, Microsoft established the Model-View-ViewModel design pattern as a means of making software development with Windows Presentation Foundation easier and more manageable. Then, around 2010, Steve Sanderson, a Microsoft employee, released his open source project called Knockout.JS, which applies the MVVM design pattern to HTML and JavaScript applications. In this video, we will take a look at presentation-related design patterns that use models and views, namely MVP, MVC, and MVVM. We'll compare these patterns specifically to show what sets the MVVM pattern apart from the others. Then we'll examine how Knockout.JS implements the MVVM pattern. The Model-View-ViewModel pattern is basically a design pattern for building user interfaces. There are a few other UI-centric design patterns that you might be familiar with, namely MVC, or Model View Controller, and MVP, or Model View Presenter. These patterns seek to solve the problem of how to pass data to and from the user interface and the underlying data model. All three of these patterns have something in common: a model and a view. So let's examine these components, and then we'll see what sets these patterns apart from each other. To start, let's look at the model. Sometimes referred to as the domain object, the model represents the actual data or information we're dealing with in our application. It's important to note that representing data is its only responsibility. The model doesn't format its data to look a certain way in the UI. Neither is it responsible for retrieving data from the server. It's simply an entity that holds some information for us. The view is the presentation of our data. This is the component that the end user sees and is usually referred to as our user interface. This layer is responsible for controlling the appearance of the data. It's also responsible for accepting user input. In the MVC design pattern, the view requests or receives information from the model and uses that data to generate its output to the user. The controller is responsible for sending commands to the model to update its state. So, in this pattern, the user interacts with the controller, which manipulates the model, which in turn is used to update the view. In the MVP design pattern, the view is passive in the way that it displays the model's data. The view does respond to the user's commands, though, and passes those events to the presenter. The presenter responds to the commands, retrieves the data, populates the model, and formats the data for display in the view. The MVVM design pattern is different in that the view is active. The view contains behaviors, events, and requires knowledge of the view model. This means that you will find view model specific references in the view. The view model is an abstraction of the view and exposes properties and commands to which the view binds. The binding aspect of this pattern involves a separate mechanism, a binder, to synchronize the view and the view model and facilitate their communication. Knockout.JS provides the binding engine for its implementation of MVVM. It also provides an API to help facilitate other aspects of programming with the MVVM design pattern. When using Knockout, your view is the HTML document. You add declarative bindings in the form of a custom HTML5 data attribute that Knockout uses to link your view to your view model. Your view model is a JavaScript object you create that contains the properties you want to bind and code to manipulate your model. And your model is a simple JavaScript object with properties to hold your data. By giving each component specific responsibilities, we're adhering to a very important design principle called the separation of concerns. Concerns are the different aspects of software. For example, the business logic layer is considered a concern. The user interface is another concern. The separation of concerns design principle is about keeping the code for each of these concerns separate. Changing the UI should not require changing the business logic code, and vice versa. This helps us build an application that is modular and simplifies its development and maintenance. In our next video, we'll take a look at how data binding is accomplished through the use of the observer design pattern and how Knockout.JS implements this pattern in its implementation of MVVM. In our last video, we learned about the Model-View-ViewModel design pattern and how it can help us separate the concerns of our application. One of the major features of that pattern, data binding, relies upon a level of communication between our view and our view model. But how is that communication achieved? In this video, we'll examine the observer design software pattern and how Knockout.JS uses it as a means of data binding in its implementation of MVVM. When we develop an application, it's quite common for our user interface and business requirements to change rapidly. If we don't maintain a separation between the UI and the remainder of the application, modifications to either portion may adversely impact the other. We also want our users to interact with our view in such a way that our view model updates automatically. And when properties in our view model or model change, we want our users to automatically see those changes. Managing such interactions without tightly coupling the layers is a problem that is solved by the observer software design pattern. The pattern is really very simple in its approach. We have the subject and its observer. The subject contains an instance of all of its observers and notifies them when there is any change in its data. The subject represents a business abstraction. Most often that's our view model. The observer is responsible for receiving change notifications and displaying data to the user. We'll find our observers in the view. When a change occurs in the subject, the observer sees this change and updates its display accordingly. Another way to think about this pattern is in a publisher-subscriber manner, whereby the observer subscribes to change events emitted by the subject. Knockout.JS gives us two data types to aid in setting up this relationship between the view and the view model, the observable and observable array JavaScript objects. We declare our properties in the view model and model as observables, or observable arrays if we're dealing with a collection, and then bind to those properties in our view using a custom HTML5 data bind attribute. When our observable changes, Knockout sees the change and updates the UI. And when the user commits a change in the UI to an exposed observable, the view model is automatically updated. Using Knockout's observable and observable array gives us the glue that binds our layers together. All we have to do is create observables and subscribe to them in the UI. In the next video, we'll investigate the JavaScript module pattern and start implementing parts of these patterns through code. In the last video, we described the observer pattern and how it relates to our models, views, and view models. We already know that for web applications, the view is actually our HTML document. But what is used to represent our models and view models? For those components, we're going to construct JavaScript objects. Now, there really isn't a way to create a class in JavaScript, at least not in the classical sense. JavaScript only deals with objects, and everything is an object in JavaScript. However, there are several ways to mimic what's known as a class found in other object-oriented languages. In this video, we're going to take a tour of JavaScript objects, closures, and finally the module pattern. We'll use the techniques we learn in this video throughout the course. Creating a simple JavaScript object is pretty easy, and there are a few ways to accomplish this. One way is to use the built-in JavaScript object constructor. As you can see, it requires some work to create an object and declare some properties with values. A simpler and more concise way to create a JavaScript object is using an object literal. This is usually the preferred way. In addition to using less code, it really drives home an important feature of the JavaScript language, which is that objects are nothing more than mutable hashes or dynamic name-value pairs. The problem with using built-in object constructors, or object literals, is that it's a one-time proposition. Once it's created, you can't really use it as a template to create more like you can with classes found in other object-oriented languages. We can, however, create a class-like structure by using constructor functions. When you assign a function expression to a variable, that variable can then be used to create a uniquely named object. You create this object by using the new keyword. It's worth noting here that using the new keyword is mandatory for this to work. Omitting the new keyword will lead to runtime errors or make your code very difficult to debug. When we create an object in this manner, the function utilizes an automatically created object literal called this, on which we can declare our properties. The this literal object is then returned even without the presence of a return statement. And that's how we access properties through our newly created object. Besides properties, we can also create methods for our object by declaring internal functions. The problem with this approach is that everything is exposed through the this object literal. There's no concept of public or private access modifiers. Everything is public. To remedy this, we can use object literals in such a way that we return everything we want to expose as public. Anything not returned in the object literal stays private. This is the JavaScript module design pattern. Also notice how the formatted function references our private member variables. This is what's known as a closure in JavaScript. We can still do better though. What if we reorganize our module such that we declare everything in the private scope? We can then create an object literal with pointers to the things we want to make public. Then we return that object literal, which becomes our public API. This is the revealing module pattern. We'll use this pattern most often throughout this course. There's one last feature of the JavaScript language that I want to point out because we'll use it quite often. You can write a function expression so that it immediately invokes itself. This is done by enclosing the function expression in parentheses, creating an execution scope, and then ending the statement with another set of parentheses, which calls the function that results from the evaluated expression. When we assign this expression to a variable, we're creating a single-use object. Notice that I don't use the new keyword to create a new object. This is an example of the singleton software design pattern. JavaScript isn't quite like other object-oriented programming languages because it doesn't have what developers have come to know as classes. JavaScript is still remarkably powerful, however, and with an understanding of a few simple design patterns, we can develop amazing applications. In this section, we learned about the MVVM design pattern and how it helps us keep components of our application separated and more manageable. We also learned about the observer design pattern and how it helps our views and view models communicate and stay synchronized. And lastly, we learned about the JavaScript module and revealing module patterns and how we can mimic class-like structures and better organize our JavaScript code. In the next section, we'll start building the sample project and use Knockout.JS to display our data. Welcome to Section 2 of Learning Knockout.JS. In our last section, we explored several design patterns including the Model-View-ViewModel pattern. We also set the groundwork for the style of JavaScript coding we'll do throughout this course by looking at the revealing module pattern. In this section, we see how to display data from our model using Knockout.JS. In this video, we're going to build a sample website and implement the MVVM pattern by creating a model, view, and view model. We're going to then use Knockout's data binding syntax to render our data to the view. Once we have our data displaying on the screen, we'll data bind to various HTML attributes to manipulate the display of our data. Before we can put Knockout to work for us, we need to set up a website and configure it. You will want to download the Section 2 code from Packt Publishing's website so that you can get easy access to some of the files used in this section. I'm using Microsoft's Visual Studio, but you can use any editor you'd like. We're going to build our sample project in a platform-agnostic manner so that we can really concentrate on Knockout.JS. To begin, let's add jQuery and Knockout.JS to our project. jQuery isn't required for Knockout.JS, but we're going to use it to make our lives a little easier when coding with our views and view models. I use the NuGet package manager in Visual Studio, but you can also get the files from jQuery's website as well as from NPM or Bower if you prefer. I added my scripts to a folder named Scripts under the root of my website project. Next, copy over the Content, Data, and Images folders from the sample project you downloaded. The Content folder contains a CSS file, the Images folder contains a few images, and the Data folder contains a JSON file that contains the data we'll use as our inventory of media items. Now let's create a model to represent a media item. Add a new folder to the Scripts folder named Models, and add to it a new JavaScript file named media.js. Next, add a JavaScript constructor function object like the one we learned about in Section 1. I'm using a Visual Studio code snippet I created, which I also included in the sample code. Take notice of the first line. What I'm doing is creating a new object literal named app, if one doesn't already exist in the global JavaScript namespace. This is a way for me to create my own namespace and not pollute the global namespace with a bunch of random variables and functions. In the following line, I'm adding our media object to the app object literal and assigning a function constructor to it. Also take note that I'm adding useStrict as the first line of my function. This means that our code will be evaluated in strict mode, which will, for example, disallow the use of undeclared variables and catch other bad coding habits. If you look at the catalog.json file, you'll notice that there are 3 properties defined per record: ISBN, media type, and name. Let's set up our function constructor to accept values for each of these properties. Then, let's create properties on the this object literal and assign the values that are passed into our function. Now let's create a view model for our project. Add a new folder under Scripts named ViewModels, and add to it a new JavaScript file named default-viewmodel.js. This will be the view model for the default HTML page we'll add later. I'm using another Visual Studio code snippet, also included in the downloaded code, to create an object using the JavaScript revealing module pattern we learned about in Section 1. We're going to ultimately display all of our media items on the page, so let's add an array called catalog to our module export. Later, we'll populate that array with our media items. Now we need a way to get our data from the catalog.json file on the server into our view model. We could code the AJAX call within our view model, but that doesn't really promote the principle of code reuse very well. Instead, let's create a new object whose responsibility it is to retrieve data for us. Then we'll use that object from within our view model. Add a new file to the scripts folder called datacontext.js and create an object using the revealing module pattern. We'll add a method to our public interface called getCatalog and point it to an internal function called getCatalog. Incidentally, these two do not need to be named the same. You can name the internal function whatever you like as long as the internal method and pointer are named the same. In the getCatalog function, we're going to use an async pattern for returning our data. Our call to the server is going to be done using AJAX, which means the call is asynchronous. Since we're using jQuery's AJAX functionality, we need to pass jQuery into our module. We'll pass the global jQuery object and refer to it as the $symbol internally. We need a way to call back to the view model when the AJAX call is complete, so we'll pass in a function to be called upon retrieval of the data. We can use jQuery's is function to ensure the passed-in callback is actually a JavaScript function. We'll use JSON call for our data and return it in the callback method. The name of the array returned in our catalog.json file is catalog, so that's the property we'll refer to in the returned data. Let's update our view model with our data context code. Open the default viewModel.js file and add the global KO knockout object and our app.dataContext object to the function parameters of our module. We'll refer to them as KO and DB internally. We want the call for our data to happen when the page loads, so let's add a method called init that we'll call later on page load. Then we'll call our data context getCatalog function and pass in a callback function. The callback is going to pass back our data, so we'll add a parameter for that. Then, when we get the data back, we'll use one of Knockout's utility functions to iterate the array. Array for each takes 2 parameters. The first is the array, and I'm being safe here in saying that if the array is null or undefined, then use an empty array so that an error isn't thrown. and the second is a function that's called on each iteration of the array. The function takes a parameter that is the current element in the array. So for each item in the array we get back from the data context call, we'll push a new app.media object into our array. Now we have our data, a data retrieval mechanism, our model to represent the items in our data, and our view model to bind to our view. So now let's create the view. In the root of the project, add an HTML page named default.html. We'll add a few divs for our page's layout, and we'll even add an h1 element for our page's title. Then we'll add our script references for jQuery, Knockout.JS, our data context, our media model, and our default view model. It's important that dependent scripts be referenced before the scripts that depend on them, of course. To verify that our scripts are working, we can call our view model's init method. Let's add a script to the bottom of the default HTML page. We'll use jQuery's ready function to tell us when the page is finished loading. Then we'll call the init method on our default view model object, which will cause our data context object to make a request to the server for our data. If you're using a version of Visual Studio prior to 2015, as well as IIS Express to serve your web pages, you will need to add a MIME map to the web.config file so that it will serve JSON files. Otherwise, you'll get a 404 HTTP response. If we set a breakpoint in Visual Studio and debug the application, we'll see that our array has been populated. If you're not using a development environment that supports breakpoints like this, you can output the array's length, for example, using a JavaScript alert or log it to the console if your browser supports it. Wow, we just took care of a lot of plumbing for our project. Don't worry though, our hard work up front will pay off when it comes time to display our data in the view. We'll tackle that in the next video. Welcome back. In our last video, we set up our website project and created our model, view, and view model. We also created a data retrieval object and successfully populated data into our array. In this video, we'll render data to our view by using Knockout's data binding syntax. We'll also get a clear picture of how the view and view model are tied together, as well as what happens when you try to data bind dynamic data without an observable. The end result will be all of our media objects displayed neatly on the page. I think you'll be impressed with how little code it takes to accomplish this. All it will take is a small amount of markup and a few simple attributes. So let's get to it. Open default HTML in your editor and add a two-column table. We'll add a T-head for headings for type and name. Then we'll add a T-body with placeholders for our model's values. Next, add Knockout's databind attribute to the T-body element. We're going to use the Knockout.JS for each binding to essentially loop through our collection of media objects. To do this, we'll pass the catalog property of our view model to which we previously assigned the results of our data call. The for each binding will iterate through each media object in our catalog array and output a new table row as defined by the T-body's child elements. Now we need to provide data binding for our properties. On each of the table data cells, we'll add data bind attributes. This time, we'll use the Knockout.JS text binding, which will cause the HTML element to display the value of our property. On the first cell, we'll pass the media type property, and on the second cell, we'll pass the name property. In order for Knockout to evaluate our view and apply these bindings, we need to tell it to what it is binding. After the call to our view model's init method, we'll add Knockout's apply bindings function and pass to it our view model. This will activate Knockout's binding engine, which will parse the current document, discover all of the data bind attributes, and execute each of the bindings. When we look at this in the browser, we'll see nothing. Well, that's disappointing. There's a good reason for it though. When Knockout's apply bindings function gets called, the page is already loaded and the binding syntax is already in place. The for each binding is assigned the catalog array and is waiting for it to update. But here's the problem. When the array is updated, there's no way for it to notify the binding that it has changed. If you recall from the video on the observer pattern in section 1, Knockout implements that pattern with two data types, the observable and observable array. If we update our catalog property in default view model to be an observable array, when it's populated from our data call, it will notify the view that it has changed. thereby triggering the for each binding. I do want to point out a performance concern here though. Notice that I populate a JavaScript array with the data first, and then I pass that to our observable array. I could have pushed each media object directly into the observable array, but that would have triggered change events for each iteration of our data. If you were looping through a really large data set, that could cause some performance issues. In most cases, it's a better practice to update observable arrays all at once. Now when we view the page, we see all of our media objects listed in our table. Beautiful. Now you see why Knockout.JS is so amazing. It allows us to separate our application into simple, organized, purposeful, and meaningful components whereby we can get a lot of benefit from very little code. In our next video, we'll examine Knockout's ability to data bind to HTML attributes, making it a very well-rounded asset for website development. Hello and welcome back. In the last video, we used Knockout's data binding syntax to render our model's data to our view. In this video, we'll take a look at different ways to data bind HTML's various attributes with Knockout's style, CSS, and attribute bindings. There are many reasons to want to control the appearance of data based on its values. You might, for example, author a stock market application where you want the displayed price of a commodity to turn green when it drops below a certain amount. Or in the case of our sample project, we might want the display of a media item to turn red and bold when it's overdue. Knockout.JS provides several options for manipulating HTML attributes to make these requirements easy to satisfy. To start, open default HTML in our project. Add a databind attribute on the row element of our table's body. We're going to use Knockout style binding and give it a value of an object literal. Let's change the CSS font weight property to bold if the media type property of our media object equals book. Otherwise, set the value to normal. Take note that if the CSS property name contains a hyphen, you will need to surround the object literal's property name with quotes, like we did here. Alternatively, if there's a JavaScript equivalent alias for the style property, you can use that as well. For example, in this instance, it would be the camel case font weight version. When we look at this in the browser, we see that the books in our inventory are bold. We can also dynamically change the HTML class attribute using Knockout.JS. This time, let's render values in the type column of our table as italic if the media type is equal to either CD, DVD, or game. After the text binding in the first column of our table's row, add Knockout CSS binding and an object literal as its value. The object literal's property name is the CSS class we'll define in our style sheet. Again, if there were a hyphen in the CSS class's name, we would have to surround the object literal's property name with quotes. We'll use jQuery's inArray function to determine if the media type is one of the three values we're testing for. Now open our site CSS file and add a CSS class named digital and define it with a font style property with a value of italic. When we look at this in the browser, we see that the media types for CD, DVD, and game are italicized. The generic way to set the value of an HTML attribute using Knockout.JS is with the attribute binding, or ATTR. Using this binding, you can set an HTML element's class attribute in a similar fashion to the way we just did with the CSS binding. Other examples of using the ATTR binding are setting up the value of an anchor tag's href attribute or setting the value of an image's source attribute. To demonstrate this, let's add a title attribute to the table cell that contains our media object's name property. After the text binding, add an attribute binding and an object literal as its value. We'll set the title attribute to the value of our model's ISBN property. When we look at this in the browser, we can see a tooltip when we hover our mouse over a media item's name. In many ways, the style and CSS bindings are shortcuts to using the ATTR binding. Knockout has another similar shortcut with the visible binding, which effectively sets the CSS style display property to none if the value you provide to it is false. Excellent! In this section, we saw how to set up a website using Knockout's implementation of the MVVM software design pattern. We created a model, a view model, and we used data binding in our view to display our data. We also looked at what's possible with Knockout.JS when it comes to data binding HTML attributes to make the presentation of our data really stand out. In the next section, we'll use two-way data binding to pass data back and forth between our view and our view model. This is where things get really exciting. Welcome back to Learning Knockout.JS. In the last section, we saw how to set up a project and display data using Knockout.JS. In this section, we're going to take a look at Knockout's two-way data binding and how it can help us create bidirectional communication between our view and view model. We'll cover the various HTML form elements and how to data bind each of them, and we'll explore several ways to manipulate form elements using other Knockout bindings. After we have a grasp on two-way data binding, we'll update our Knockout Media sample project by adding some views and view models to administer our media items and borrowers. In this video, we're going to dive into two-way data binding with the HTML input element. We'll data bind to a property in our view model and demonstrate what happens when we update the text in the input element. We'll also data bind an HTML button to trigger a function that will update the property so that we can see how the HTML input responds to the change. To get started, create a new HTML page for our view. Also, create a new JavaScript file for our view model. I'm going to name them Data Binding HTML and Data Binding ViewModel.js. After you add the boilerplate code for the view model, switch over to the HTML and add your style sheet. Go ahead and set up your page title. And I'm going to go ahead and add some divs for our layout and content, as well as an h1 tag for our title on the page. Next, we'll want to add our script references, jQuery, Knockout.JS, and our view model. Then we'll add the initialization code to bind our view to our view model. Like we did in the last section, we'll use jQuery's ready function to signal us when the page is loaded. And then we'll ask Knockout to apply our bindings. Alright, we should be ready to go. Although the page isn't very exciting yet. Our plan is to bind an HTML input element to a property in our view model, so let's first add that property. We'll simply add a Knockout observable called message to our view model and initialize it with an empty string. Now we'll add an HTML filled set and an ordered list for our form elements. In the first list item, we'll add an HTML input element with a data bind attribute. When binding an HTML input element, there are two Knockout bindings you can use, value and text input. The value binding simply binds the value attribute of the HTML input, text area, or select elements. The text input binding is a little more specialized and limited to the HTML input and text area elements. It provides instant updates to and from the element's value attribute, the same as Knockout's value binding, but it also accounts for other types of user input like dragging and dropping values into elements, or when the user copies and pastes from the clipboard. In most cases, when using an HTML input or text area, use the text input binding. Great! So now we have our HTML input bound to our message property, but how can we tell if the property actually updates? Well, there are a couple of ways. First, let's look at a built-in function of Knockout's observable object, the subscribe function. It allows us to see changes to an observable as they occur. Add a private initialization function to your view model and call that function before returning the module export. Then, inside the initialization function, call Knockout's subscribe function on the message property. The subscribe function's first parameter is a callback that passes the updated value of the observable whenever a change occurs. We'll show the value in the UI using a JavaScript alert. If we open our page in a browser and paste some text in the HTML input element, we'll get an alert that shows the current value of the message property. Of course, there are better uses for the subscribe function, but in this example, it helps us to see what's happening behind the scenes. Another way to show our output is to simply add an HTML element to our view and data bind the message property to it. Open your HTML document and add another list item with an HTML div element. Insert a data bind attribute and use Knockout's text binding to bind the message property from our view model. Go ahead and comment out the JavaScript alert in the initialization function before viewing the page again. This time, when we type in the HTML input, The value updates the message property in our view model, which in turn is observed by the UI and output to our div. We've seen how the view model gets updated from the view. Now let's update the message property directly and watch how the view responds. We'll start by adding an array of strings. I chose different colors for each array item. Then, we'll add a public function called loadMessage that updates our message property with a randomly chosen array element. And we'll format it out with a nice message. To call this function, let's add a button to our HTML field set and data bind our loadMessage function with Knockout's click binding. Notice that we use a reference to the loadMessage function as opposed to calling the function with parentheses. Whenever the button is clicked, it will call our function and update the message property. This change is observed by the UI bindings, and our HTML elements are updated with the new value. Congratulations! You can now perform two-way data binding between HTML input elements and a view model. And I think you'll agree that it takes very little code to accomplish this simple yet amazing feat. In the next video, we'll cover the remaining commonly used HTML form elements and show how to data bind them using Knockout's built-in bindings. Hello again! In the last video, we saw how to perform two-way data binding with the HTML input element. In this video, we're going to examine the remaining commonly used HTML form elements and see how to two-way data bind them using Knockout.JS. We're going to build on what we did in the last video by adding a series of HTML field sets to showcase data binding several HTML form elements. Let's start with the HTML select element. Open the data binding HTML document in our project and add a field set with an ordered list. Then add an HTML select element to the first list item. Let's bind the array of color names we used in the last video to this element. In the data bind attribute, we'll use Knockout's options binding to specify the array to which we're binding. Now let's use the options caption binding to specify a default value for our dropdown. Lastly, we'll use the value binding to bind an observable in our view model. We'll add the color property in a moment. Add a second list item and insert a div element with a data bind property which uses the text binding to observe our color property. Now switch over to the data binding view Model-JS and add a public property named color and assign it to a Knockout observable. When we look at our page in a browser, we'll see an HTML select populated with our colors. And when we select an option, the value appears in our div. You can also data bind objects to a select element. Open data binding view Model.js and add an observable named keyValuePair and an array named keyValuePairs. Assign an array of object literals with a property named key and another property named value. I'm using ordinals for my keys and values. Now let's add some HTML to our view. Create another field set with an ordered list, and in the first list item, add an HTML select element. We'll bind our keyValuePairs array using the options binding and give the element a default value using the options caption binding. We'll also bind the keyValuePair observable using the value binding. Because we're binding objects, we'll need to specify what appears in the list of options. For that, we can use the options text binding and assign a function that returns each object as it iterates through the array. We'll capture each array item and return its key property, which will be what the user sees in the dropdown. Now, in the second list item, add a div to serve as our output and bind the keyValuePair property to the text binding. There's a problem here though. Our keyValuePair property is storing an object, which means that we'll have to specify one of its properties to display in our div. Also, before an option is selected, as well as when the user selects the default value, our object is undefined. We can work around this by using a ternary operator to test if the object is defined. If it is, we'll return the object's value. If it's not, we'll return an empty string. One thing to take note of here is the use of parentheses when evaluating the keyValuePair property. Knockout's observables are actually functions, so you need to call the function to get the underlying value. When doing simple data binding, Knockout tests if the bound property is an observable, and if it is, then it evaluates it as such. We're using a ternary expression here though, so it's not so simple. That's why key-value pair is evaluated using parentheses. We have to get to the value of the underlying observable. But the value property doesn't use parentheses, even though it is an observable. Knockout figures that out for us. When you take a look at the page in the browser, you'll see the option value displayed when you select an item in the drop-down. Now what if you wanted the property of a bound object as the selected value? Well, there's a binding to handle that as well. Add another field set and set it up like the last example. This time, though, add an options value binding to use the object's value property. Also note that I'm using the property names for the options text and options value, key and value, instead of functions. This is the preferred method of accessing those properties, though using functions can be helpful if you want to alter them in some way. For our output, let's add a new observable called ordinal to our view model. We'll bind it to our select using the value binding, and then to our div using a text binding. As you can see, the result is the same, but how we got there is quite different. Multi-select lists are pretty easy with Knockout.JS too. Instead of a single select item, the select element exposes an array of selected items. We'll want that array to dynamically update our UI, so let's create a new property in our view model called chosen colors, and let's make it an observable array. In our view, create a new field set with an ordered list, and in the first list item, add a select element with a size attribute and a multiple attribute. We'll data bind our colors array with the options binding. And we'll use Knockout's selected options binding to data bind our chosen colors observable array. For our output, add a new list item that contains an unordered list. We need to iterate our chosen colors and output its values. Knockout's for each binding will work well for this. In each list item that's output, we'll use the text binding to display the value of each array element. But how do we refer to each array element? Fortunately, Knockout provides a type of context that helps us here, the data context. We'll talk about context more in a later video, but for now just know that the data context refers to the current object being bound. Next, let's look at radio buttons. Add another field set and ordered list to our page. We'll use our array of colors to create a series of radio button input elements. This time, though, let's use a different technique to iterate through our array. Knockout has what's called a containerless control flow syntax, or virtual element, that's based on HTML's comment syntax. Within the first comment, type KO for each, and assign our colors array. Within the second HTML comment, type /KO to end our execution scope. Between the two sets of comment tags, insert an HTML input element and set its type to radio. Radio buttons work in groups that are named the same, so we'll name each input color. To data bind our input element, we'll assign the data context to our value binding. To get the value that's selected, though, we'll use Knockout's checked binding. We'll assign our view model's color property to this binding, but there's a hurdle to overcome first. We're within a loop of our colors array, which means that this area of our HTML is only aware of each item in the array. If we simply assign our view model's color property to our checked binding, nothing will happen because color doesn't mean anything in the context of each array item. What we need to do is reach outside this area to the parent context to access the color property. By using Knockout's parent context, we can successfully bind the color property in our view model. Again, we'll go more in depth on context in a later video. Now let's add a label element and data bind the current array item using the data context against the text binding. And so that our list looks nice, let's place a break element to separate our radio buttons onto separate lines. Our output is simply a div that's data bound to our color property. Now let's take a look at it in the browser. Pretty cool, right? Checkboxes are much simpler to data bind. Add a new property named isChecked to your view model and make it an observable. I'm going to default the value to false. create a new field set, and add an ordered list with the first element containing an input with a type of checkbox. We're going to data bind the input using the checked binding and assign it our isChecked property. Add another list item and insert a div that's also data bound to our isChecked property. When we look at this in the browser, we'll see that when we check the checkbox, the value changes to true, and when it's unchecked, it goes back to false. Pretty simple. The last thing we'll look at is how to data bind an HTML form element. Set up another field set, but this time wrap the ordered list with a form element. In the first list item, add an input element and data bind it to the message property using the text input binding. Then, after the ordered list, add an input of type submit and give it a value of show message. Now, on the form element, data bind it using Knockout's submit binding. We'll create a function in our view model named showMessage to handle the event. Now switch over to the view model and add a function named showMessage. We'll use a JavaScript alert to display our message when the form is submitted. Because the message property's value might be unassigned or empty, we can use a ternary expression to output a default message. When we click the button in the browser, the form is submitted and the showMessage function is called. Well, pat yourself on the back because you're now equipped to handle almost any HTML form with style and ease, and it's all thanks to Knockout.JS. In our next video, we'll take a look at a few bindings that will help control the appearance and functionality of HTML form elements. Welcome back. In our last video, we examined all of the commonly used HTML form elements and how to perform two-way data binding using Knockout.JS. In this video, we're going to look at how to enable and disable HTML form elements using data binding. We're also going to examine how to set focus to form elements using Knockout. And lastly, we'll update our sample project with data management views using what we've learned about two-way data binding. We'll start by updating our data binding HTML page to showcase the enable, disable, and has focus bindings. First, let's look at the enable binding. In the first field set, after the load message button, add an HTML input element with a type of checkbox. We'll use the checked binding to enable and disable our input element that's bound to the message property. We'll add the isEnabled property to our view model in a moment, but let's go ahead and set it up with the enable binding on our input element. Now switch over to our view model and add the isEnabled property as an observable. We'll give it a default value of true. When we deselect the checkbox, the input element becomes disabled. The disable binding works in the opposite manner. It disables the associated element when its value is true. On the second field set, add another checkbox and data bind it using the checked binding against a property named isDisabled. We'll add that to the view model in a moment. Now, on the second element in this field set, add a disable binding and assign the isDisabled property. Switch over to the view model and add the property as an observable with a default value of true. When we look at it in the browser, the select element is disabled until we uncheck the box. Now let's take a look at the has focus binding. This binding associates an HTML element's focus state with a view model property. To demonstrate, let's add the has focus binding to the select element in the third field set. We'll set it up to bind against a property named isFocused. In the view model, we'll add an isFocused property and give it a value of false. Then, in our init method, let's give it a value of true. When we refresh the page, we'll see that the select element has focus when the page loads. Now that we have a pretty firm grasp on one-way and two-way data binding, let's enhance our Knockout Media project. To get started, copy over the data folder from the Section 3 code available on Pact Publishing's website for this video course. There are two more JSON files that we'll use going forward, borrowers.json and mediatypes.json. Also, copy over data context.js and replace the existing version. Since we're going to start using two-way data binding to change our data, we need a way to persist those changes. Normally, you'd want to use a database or some other method of persistence, but that would distract us from the task at hand, which is learning Knockout.JS. Instead, I've set up data context.js to write our changes to the HTML5 local storage mechanism. You'll need to use a modern browser, however, but the most recent versions of Internet Explorer, Google Chrome, Firefox, or Safari will do just fine. You will also need to copy over the site.css file in the content folder to update some of our styles. Now let's add two new HTML documents to the root of our project. We'll name them Media.html and Borrowers.html. Go ahead and set up the style sheet, and we'll add the divs for our layout and content. And since we're adding more pages, let's go ahead and add a menu to all of our pages so that we can navigate better. And we'll go ahead and copy this over to the other page and update the content. This is what our page should look like now. We'll also need view models for our new views, so let's add two new JavaScript files, Borrower-ViewModel.js and MediaViewModel.js. We'll add those to the View Models folder and supply them with our boilerplate revealing module code. On our Media HTML view, we're going to want to display an editable list of our media objects, so let's set up our MediaViewModel.js file first. We'll of course need an observable array of media objects, so let's add a catalog observable property for that. And once we have our catalog displaying on the page, one of the things we'll want to edit is the media type property. So let's create an observable array so that we can bind our select elements to that data. Something to consider here is the order in which we load our data. When our editable list of catalog items renders to the page, we'll want a select element per media object that is populated with data from our mediatypes.json file. If the catalog renders before the media types data is available, the select elements won't be able to set the selected value. With that in mind, let's get the data for our media types first, and then get the data for our catalog so that everything is available when the catalog renders. What we'll do is set up a private getCatalog method and make the call to our data context getCatalog method. Just like last time, we'll use array for each to iterate the data we receive back from our data context. Then we'll add each media item to our local array. Then we'll assign our local array to our observable. Lastly, we'll need to make sure to call the private getCatalog after the media types are retrieved. In our view, we'll set up a table with columns for ISBN, media type, and name. We'll data bind the tBody element to iterate our catalog, and then we can set up our editable data points. And we don't want the users to change the ISBN because it's system generated. So we'll use an HTML text input element and data bind its value to ISBN, but we'll use Knockout's enable binding to disable it. For the media type column, we'll use a select element to display the media type data we get from the JSON file. And take note that we need to use the parent context to get access to our view model's media types property. For the name property, we'll simply use a text input binding on an HTML text input element. The result is a list of our media objects, which are now editable. The last thing we need to do is provide a way to save our changes. Add an input element with a type of button and a value of save. We'll also add a data bind attribute and bind a method named save assigned to the click binding. Then, in our view model, add a public save method. In that function, use Knockout's ArrayForEach utility function to iterate our catalog array and save each item using the SaveMedia function in our data context. We'll need to transform our observables to a plain JavaScript object, though, before we save it. We can accomplish this by using Knockout's to.js method. Now when we make a change in one of our HTML form elements and click the Save button, we can navigate to the dashboard page and see that the change persisted. The borrower's view and view model are set up in much the same way and are available in the code on Pact Publishing's website. Before you look at those, though, I'm going to challenge you to complete those files yourself. Just take your time and remember what we've learned. I know that you can do it. This was a very important section on our journey to learning Knockout.JS. Two-way data binding is what Knockout is all about, and I think you'll agree that it's one of the most powerful tools now in your arsenal. There are multiple ways to data bind several of the commonly used HTML form elements, and we looked at several of those. We also saw ways to control form elements using bindings like enable and hasFocus. In the next section, we'll tackle context in Knockout.JS. We got a peek at context in this section, but there's so much more to it. See you then! Welcome to Section 4 of Learning Knockout.JS. In the last section, we looked at two-way data binding. In this section, we're going to examine the concept of context in Knockout.JS. Context is central to the MVVM pattern and data binding, so it's important to understand it if you're going to take full advantage of the pattern. We'll take a look at the commonly used context objects in Knockout. We'll also look at templates and how context is used when data binding them. And we'll cover an important object-oriented concept known as composition and how we can combine multiple view models in a single view model and view. In this video, we'll use the for-each binding again, but we'll go a little farther this time and discuss specifically the role of context when using this binding. Then we'll introduce the with binding and demonstrate how context is important when binding with it. The root context object is used quite frequently, so we'll cover its use, and we'll also look at the element context object, which can be useful at times. To start, open our project and add a new HTML page named foreach.html to the root of the project, and a new JavaScript file named foreachViewModel in the ViewModels folder under scripts. Go ahead and insert our boilerplate revealing module code in the script file, and set up the HTML page with the necessary references. And of course, go ahead and set up our initialization code so that we can bind our view model to our view. For this demo, we're going to need some data that's a little more complex than what we've been working with. So let's create a property in our view model that represents some products and the colors in which they're available. In the view, let's display the array of products in an unordered list and the colors per product in an embedded unordered list. To data bind our array, we'll use the for-each binding like we did in previous videos, only this time we'll use explicitly the full chain of context objects available in Knockout.JS. In the outermost unordered list, insert a data bind attribute and set up the for-each binding. The current binding context is simply called $context. It represents the setting in which our data is accessed. In this case, the context is the setting in which our view model resides. Like we saw in a previous video, context has data, and you can access that data using the $data context object. In this instance, data refers to the view model itself. To complete this statement, we can access the products property off of the $data context object. Of course, as we saw in previous videos, we can bypass the $context and $data context objects and go straight for the property. The context objects are simply implied. We can data bind the h4 element in a similar fashion. Here, the $context object refers to the individual element in the products array. Its context has $data as well, and it refers to the properties and methods included in the array item. Here, we'll access the name property. Here's what it looks like thus far in the browser. There's a special context object that's only available within the for-each binding. It's called the $index context object, and it represents a zero-based index of the current array entry. If we add this object to our text binding, you'll see that each item that's output is numbered, starting at 0. Note that because we're evaluating the $index context object as part of a string concatenation, we need to call it using parentheses so that we can get to the value of its observable. Otherwise, we could just reference it without the parentheses. Data binding our colors property from the current context is the same as accessing the name property, only now we're creating a new context within this for each binding, a context that contains each individual array of strings for each of our product's colors. At this point in our code, we have three distinct contexts. The ViewModel's context, which is bound to the page by using the applyBindings method, the outermost unordered list, which is established by the for each binding on our products property, and the innermost unordered list, which is created by the for each binding on the colors property of each product. Each of them have their own $context object, which can have its own $data context object. We can see in the browser that each level of for each bindings has its own $index context object that's independent of the others. We can access the parent context of any given context too, except the root context, of course. Knockout provides us with the $parent context object, which is the immediately preceding context in the hierarchy. Here, we can output the $index context object of the outermost unordered list within the innermost unordered list. Now let's move on to our next binding. The with binding in Knockout.JS establishes a new binding context so that child elements are bound within the context of the specified object. To demonstrate this, create a new HTML page named with.html and a view model named with-viewModel.js with the appropriate references and boilerplate code. We'll use animal taxonomy for this demo because it's a fairly familiar hierarchical set of data. In our view model, we'll add a public property named taxonomies and populate it with some sample object literals. In our view, we'll use Knockout's virtual element syntax to create a loop over our taxonomies objects. We'll add a div element here and use the with binding, which will create a new binding context specific to the animal classification. Anything bound within this div element is in the context of that object. If we add another div element inside the animal div element, we'll see that the properties we're limited to are the name and kingdom property, which is on the next object down the chain. We can continue this until we reach the bottom of the hierarchy. Now comes the fun part. We're going to output each level's name property from within the innermost context. We can do this by accessing the $parents context object, which is an array of all the context objects in the hierarchy. The array starts at 0, which is the next closest parent context. In this case, the $parent or $parents subscript 0 would be the genus object. If we were to go all the way down to the first object in the hierarchy, we would be accessing $parents subscript 6. Incidentally, I included the name of the classification in each element just for reference. The text binding will overwrite the value. At this point, we're way down in a long hierarchy of objects, but what if we wanted to access a method in the view model? That's where the $root object context comes in handy. The $root context is the topmost parent context, which, in our case, is the with-viewModel revealing module. Let's add a public method in our view model to display the entire object. We'll pass the animal object and format a message for a JavaScript alert. To trigger the method, we'll use a click binding on the h1 element. The click binding by default sends the current data object and the event object. We need to pass the $parents subscript 6 object though, which presents a problem. We can solve this dilemma by wrapping the call to our ViewModel's method in another function and passing our context object. When we click on one of the h1 elements, we get an alert that shows each level of the object hierarchy. The last item we'll look at is the $element context object. This object represents the DOM element of the current binding. To demonstrate how it works, we'll add another public method to our view model which will accept an HTML element and use a JavaScript alert to display its inner text. In our view, we'll assign a function to our click binding, and from within that function, we'll call our display method and pass it the $element context. And let's copy that and put it on our other elements. When we click on the elements, the inner text is displayed. Very cool. Context is a concept that is a little tricky to understand at first. We'll continue to use the various context objects throughout the rest of the videos, so if you're still having trouble, hang in there. It'll make sense with a little practice. In the next video, we'll introduce templating and binding to templates with Knockout.JS. Templates also create their own binding context, so we'll continue learning about context. Welcome back! In the last video, we learned about the various data context objects available in Knockout.JS. In this video, we're going to learn about rendering templates in Knockout.JS. We'll use what we've learned about context and apply it to developing with templates. We'll also cover how to alias our context with the as property. Lastly, we'll examine a technique to load templates from an external source. Let's start by adding a new page, template.html, and a new JavaScript file, template-ViewModel.js, to our project. Insert the boilerplate code for our revealing module and set up the HTML page with the appropriate references the same way we've done in previous videos. We're going to output two tables in our view, one for books and one for magazines, and share the code for those tables in a template. With that in mind, let's set up our view model with an initialization method that retrieves our data using the getCatalog method in our data context object and populates two public properties for our books and our magazines. Ideally, you would want to query the data server-side and only select the data you need, but we're not dealing with something as advanced as a relational database for our data, so this will suffice. In our view, we'll add a new script element of type text.html. By setting the type to text.html, we're ensuring that the contents of the script element are not executed as JavaScript. We'll also give it an ID attribute so that we can refer to it later. Inside the script element, add a 3-column table for the ISBN, media type, and name properties of our media objects. To data bind the table rows, we'll use the for-each binding and assign the $data context object. We'll also set up the text bindings for each of our table cells. To use the template, add two div elements with data bind attributes. We'll use Knockout's template binding and assign an object literal. Next, we'll assign the script element's ID to a name property which tells Knockout which template to use. Then we'll add a data property and assign our view model's books property to one div and the magazines property to the other. The data property of the template binding is what passes our data to the template. Once our data has made its way to the template, we can refer to it using the $data context object we learned about in the last video. When we open our page in a browser, we'll see our two tables both using the same code to output different sets of data. We can make our template a little easier to understand by using the as property of the template binding to alias our data. Add the as property to the template binding and assign it a value of catalog. Then, change the template's for-each bindings assignment to catalog as well. The result in the browser is the same, but our code is easier to follow. This is especially helpful if you're nesting for-each bindings because the context and data references can get pretty confusing. You could use the $parent related bindings we learned about in the last video, but aliasing them is a much better approach. Sharing templates is very helpful to reducing the amount of code we have to write, but our approach thus far has a serious shortcoming when we want to share templates across pages. Fortunately, there's a technique we can use to work around this. Create a new directory in our project named templates and add a new HTML file named mediatable.html. Then copy and paste the table we used in template.html into this file. We'll use the more generic $data context in our for-each binding this time since we don't know if an alias will be used in all future implementations. Now, open template-ViewModel.js and add a private property named _templates and assign an array to it with a single element value of mediatable, which is the name of our template file minus the extension. We're only using one template in this example, but we'll use a technique that supports the downloading of multiple templates. Now add a public method named loadTemplates. Thinking ahead, we'll want all of our templates to be downloaded and available when Knockout binds the view model after the page loads. This means that loadTemplates will need to be called before applyBindings is called, so we'll use the callback pattern to accomplish this. We'll loop through each item in our templates array and use jQuery's get method to download the content of our template files. Then we'll insert that template content into a script element that we append to the HTML body element. We'll need to know when all of the templates are downloaded, so we'll use a counter variable to let us know when the number of downloaded files is equal to the length of our templates array. Then we'll call our callback method, which will return us to the view and the applyBindings method call. To implement this, create two HTML files in the root of your project named External Template Books HTML and External Template Magazines HTML. We'll set up the files the same way we have our previous examples. I'm going to use Knockout's virtual element syntax to establish my template binding. In the External Template Books HTML view, we'll pass our Books ViewModel property to the template's data property. And in the External Template Magazine HTML view, we'll pass our Magazines property to the data property. In our jQuery ready method, we'll call loadTemplates from our view model, and in the callback, we'll call ko_applyBindings to initiate the rendering of our page. The result is the same as before, but now our tables are split between the two pages, both sharing the same template. Knockout's templating feature is something that I use quite frequently. It helps me to reduce greatly the amount of code I have to write and maintain. It does add a new binding context though, so be aware of that when setting up your bindings. In the next video, we'll examine how to bind multiple view models to a single page, as well as a technique to combine multiple view models into a single view model. Hello again! In our last video, we looked at using templates to data bind our view models. In this video, we're going to examine how to bind with multiple view models from a single page. This is a viable technique, but there are several shortcomings to this approach which we'll discuss. Then we'll look at how to combine multiple view models into a single view model as a solution to those shortcomings. Our goal for this example will be to render tables for our media names and borrower names with a button for each record to trigger an alert with more details about that record. To start, add a new page to our project named multipleApplyBindings.html. We won't have to create any view models for this example. Instead, we're going to add references to our existing view models, BorrowerViewModel.js and MediaViewModel.js. Set up script references to those files as well as the other necessary dependencies. Since both media and borrowers have a name property, we can set up a single table to display them and share it through a template. Now we'll add an h1 tag for our titles and a div that will reference our templates. We'll use the catalog as the data for our media titles template. And we'll just duplicate this and set it up for our borrowers. And change catalog to borrowers. And one other thing that I'll need to do here is add an ID on each of these divs. We'll use that in a moment. Knockout.JS doesn't allow us to data bind both of our view models to the same element in the same page. We can't simply call ko_applyBindings on both view models because that would bind them both to the same element. Instead, we'll pass an instance of an element as the second optional parameter of the applyBindings method. This parameter is the HTML node to which you want to data bind. Now let's data bind our button element. But wait, there's a problem. To which view model do we bind? Normally we'd use the click binding with something like root.display, but we don't have a single root view model from the context of the template or the for-each binding. Our only option is to target the models and add a method there. The best option is to override the default toString method with one of our own. You can do this by reassigning it from the prototype object. Now we can data bind our button element to a function that alerts data.toString and see the details in the browser. Now when we click on a button, we can see the details. That you cannot share a context between view models is a serious drawback to this approach. If your bindings are going to be totally separate, this is a viable option. In most cases, though, I think you'll find your scenarios will require you to have a better line of communication between your view models. A better approach is to use the object-oriented design principle of composition. Put simply, composition is the act of combining relatively simple objects into more complex objects. To demonstrate this, create a new JavaScript file named composition-ViewModel and insert our boilerplate revealing module code. We'll pass in our borrower view model and media view model in the module's constructor and assign them to a public property. We can go ahead and implement our centralized code for our details method too, and alert the toString output the same way we did in the last example. When the button is pressed, our data object is passed to the details method. This will allow us to call the toString method. Add a new HTML page named composition.html and set it up like our last example. We'll need to be sure to add our composition view model reference as well. I'm going to use Knockout's virtual element syntax this time, but you can keep the divs if that's what you prefer. For the data property of our template binding, we'll assign the appropriate arrays from our respective view models using the public properties we set up in composition-ViewModel. For the media titles, I'll use media-ViewModel and get the catalog. We'll duplicate this for borrowers and update it accordingly. Then, to establish the binding for the page, we'll use the apply bindings method in the way we've become accustomed to throughout this course. The last thing we'll want to do is wire up our button call to the details method in our view model. The results are the same, but the implementations are very different. Again, I suggest you favor composition over multiple bindings. It's much more flexible in a majority of situations. Congratulations! You have just completed a section on what is likely the most difficult of topics to understand in Knockout.JS. In order of importance, I personally rank context as the most important concept to understand when developing with Knockout. In this section, we examined most of the data context objects you'll ever use, and we learned about templates and how to best take advantage of them. We also looked at ways to use multiple view models when constructing our views. In the next section, we'll look at computed observables, one of my favorite features in Knockout.JS. Greetings! In the last section, we learned about context in Knockout.JS. In this section, we're going to look at a really nice feature in Knockout called computed observables. We're also going to look at subscribing to changes in observables and performing actions based on those changes. This video is all about computed observables. We'll cover how to create and use computed observables and pure computed observables, as well as a variation that makes them writable. Computed observables are one of my favorite features of Knockout.JS. They're functions that have dependencies on other observables, and when they change, the computed observable automatically updates. You can, for example, perform a calculation using the values of other observables and data bind to the value. If any one of those dependent observables changes, the computed observable also updates its calculation and then notifies the subscribers. We're going to update our project to data bind to a sorted list of data that we will access through a computed observable. To start, open MediaViewModel.js and add an undefined public variable named sortedCatalog. Then, in the init method, assign the variable to a knockout computed. The first parameter of the computed function is a callback that returns the result. The second parameter is the value of the JavaScript this object literal that is used in the callback. Think of the second parameter as the context used in the callback. In our case, we'll pass our module export as the context since we're going to refer to the public observable properties in the callback. The reason we're defining the computeds within the init method is because computeds are evaluated when they're declared. If your computeds use other properties that are not yet declared or defined, you're likely to get unexpected results or errors. By keeping the declarations separate from the definitions, you can avoid this issue. Our sorted catalog computed will return the catalog observable after it has been sorted. To sort, we'll use the sort function available to the observable array object. I'll sort first by media type and then by name. Notice that I refer to the catalog observable using the this object. I can do this because I passed in the module export as the context. In our view, all we need to do is change the for each binding's assignment to sorted catalog. When we look at it in the browser, we can see that the list is now sorted. If we were to dynamically add or remove an element from the catalog observable array, that change would be reflected in our view and automatically sorted through the sorted catalog computed observable. Now, open Borrower-ViewModel.js and add a public property named Sorted Borrowers. This time, in the init method, assign the property to Knockout's pureComputed function. The parameters are the same as the computed we did in the Media-View-Model example, and the sort is the same, except that we're going to sort on name first and then email. Now we can switch over to the view. Update the view by changing the for each binding, and then look at the results in the browser. In this scenario, the behavior of the computed and pureComputed is the same. However, Knockout's pureComputed observable offers some performance and memory utilization advantages over the plain computed observables. In most cases, you're going to want to use pureComputed. But if you're going to use the computed observable to run a callback based on value changes in other observables, which honestly isn't a very common task, then you'll need to use a computed observable. Computed observables are also great for presenting a different perspective of your data. Let's change the dashboard view of our sample project and create a table of media items currently in our possession and another table of media items that have been borrowed. First, let's update our media model to accommodate borrowers and due dates. Then we'll add data to a few of our records in catalog.json for borrowers and due dates. Open default ViewModel.js and add two public properties, one named borrowed and another named possessed. We'll assign undefined to them for now. Then, in the init method, assign Knockout's pureComputed methods to these new properties. For borrowed, we'll return a filtered array using Knockout's arrayFilter method, testing if borrower and due date are not null or undefined. Then we'll sort the results by due date. For possessed, we'll return a filtered array by testing if either borrowed or due date are null or undefined, and we'll sort this array by media type and name. Now open default HTML and change the for each binding in the table to bind against possessed. Then use Knockout's virtual element syntax to test if the borrowed array's length is greater than 0. Insert a table between the virtual element tags that displays columns for media type, name, and borrowed by, as well as due date. We'll use the for each binding to display data from our borrowed computed observable. Let's also change the color of the text in a row to red if the media item is overdue using the CSS binding. When we look at this in the browser, we'll see that there is a table for what we have in our possession as well as a table for what has been borrowed. Both of these tables are driven by the same set of data. We're just creating subsets of data to meet our needs. Most of the time, you're only ever going to use computed observables to read data. However, Knockout does provide a way for you to write to a computed observable in order to change the underlying observables. One practical use of this feature is to use a computed observable as a value converter. Add a new JavaScript file to the ViewModels folder in your project named ComputedViewModel.js and insert the boilerplate revealing module code. Also add a new HTML page named ComputedHTML and insert the appropriate JavaScript references as a reference to the file we just created. In ComputedViewModel.js, create two public properties, phone and output. Assign undefined to phone and make output an observable. Now, in init, redefine phone as a pureComputed. Instead of using a function as the first parameter, use an object literal. Add a property to this object literal named read and assign the output variable by referencing it from our module export. Now, add a property named write, and assign a function with a single parameter. The parameter of this callback function is the new value of our computed observable. Let's assign this new value to our output observable, but first replace any non-digit characters as an empty string, ignore anything after the 10th digit, and format it as a phone number. Now, in the computed HTML view, add an HTML input and data bind the text input to phone. Also add a div and data bind the text to output. When we type 10 or more numbers in the HTML input, we'll see it reformat itself as a standard phone number. Computed observables are a very powerful and very flexible feature of Knockout.JS. I'm sure you're already thinking of ways to use them in your next project. In our next video, we're going to take a second look at another powerful feature, the ability to subscribe to changes in our observables. Welcome back! In our last video, we examined computed observables. In this video, we're going to take a look at observable subscriptions and how we can intercept changes as they occur. We're also going to investigate how we can get a before and after look at our observables when they change. Cascading select lists are a common feature of many web applications. They are also somewhat problematic in that they can sometimes require complicated code to make them work properly. We're going to demonstrate a practical use of Knockout's subscribe function available to observable objects by using it to create cascading select lists. You'll want to update your data context.js file with the one found in the downloaded code for this section. Now add a new JavaScript file to the ViewModels directory of your project named subscribe-viewmodel.js and insert the boilerplate code for the revealing module pattern. Also add an HTML page to the root of your project and name it subscribe.html. Go ahead and set it up with the necessary script references as well as a reference to the view model you just created. We're going to create a primary select list of borrowers and a secondary select list of media items they have borrowed. To support the select list, add properties to store observable arrays of borrowers and media items as well as observables to store the selected items of each list. Add an init method too, and make a call to our data context.js for the borrowers.json data and populate our borrowers property. Also make sure to pass in Knockout and our data context. Switch to our view and add the divs for our layout and content. Then add a field set with an ordered list and two list item elements. In each list item element, add a select element and set up the data binding to properly bind to our borrower and media object arrays. We're going to use the borrower's email address to look up what media items they have borrowed, so that's what we'll use as the selected value of the borrower's select list. Once a media item is selected, we'll display the properties of the selected object, so we'll exclude the options value binding from the catalog select list and assign the selected object to the media property. We want to look up the borrowed media items from the catalog.json file when a borrower is selected. One way we can do that here is to subscribe to the borrower property and make our data call when its value changes. Switch back to the view model and add a subscription to the borrower properties in the init method. The subscribe method takes three parameters, of which the second and third are optional. The first parameter is a callback function that passes back the value of the observable. The second parameter is to pass in the context of the this object literal, the same way in which the computed observable uses its second parameter. What we will do in the callback function is test if the changed value is not null or undefined, make a call to the getBorrowedCatalog method in our data context, and populate the catalog property. Note that we're not able to take advantage of the this object we passed in as the second parameter of the subscribed function within the getBorrowedCatalog method because we're in a different JavaScript context at this point. When viewed in the browser, you'll see that when a borrower is selected that has a borrowed item, the second select list is populated with those media items. To make the UI a little friendlier, let's add an enable binding to the catalog select list and only enable it if the catalog observable array has any items. Next, let's add a field set to display the property values of the selected media item. We'll hide this section by not binding to it if the media property of our view model is null or undefined. Now when a media item is selected, it displays itself in the view. There's another interesting feature of the observable subscription that you might want to be aware of: the ability to obtain the previous value of an observable, that is, the value before it's updated with a new value. Add another subscription to the borrower property in the init method. This time, though, add a third parameter value before change. Then add another public observable property to our module export named PreviousBorrow and pass to it the value returned from this subscription's callback. Switch back to our view and add another field set to display the previously selected borrower. We'll bind our PreviousBorrow property to a div element. View it in the browser and make a few selections. You'll notice that the previously selected borrower is displayed, which is the value before the assignment from the select list. Awesome! In this section, we learned about a few features of Knockout that can really make our applications easier to develop, namely computed observables and subscriptions. Knockout's computed observable, and pure computed observable, of course, is a feature that I use in almost every application I write. And whereas features like writable computed observables and the subscribe method aren't tools that I use frequently, they're definitely worth keeping in my toolbox. In the next section, we're going to finish our Knockout Media sample application by adding some more advanced features using custom functions, custom bindings, and extensions. I'll see you then. Welcome back to learning Knockout.JS. In the last section, we learned about computed observables and subscribing to observables. In this section, we're going to look at ways to extend Knockout's capabilities with custom functions, extenders, and bindings. Knockout provides a way to create functions that extend the core data types, namely subscribable, observable, observable array, and computed. Each of these data types has an object named fn to which you can attach your custom functions. Let's say, for example, that you wanted the ability to filter any observable array by one of its properties values. You could do it with a computed, or preferably a pure computed, but if it's something that you want to do repeatedly, that would mean a lot of code to write and maintain. Custom functions allow you to centralize that code and associate it specifically to a data type. In this video, we're going to look at how to add functions to the fn object by constructing a custom function that filters an observable array based on a property value. Then we'll use this custom function to display our media catalog filtered by media type. The example we're going to implement is actually covered on Knockout's website. It's an extremely useful extension, however, and one that I use quite often. To be honest, I haven't found many circumstances where I've needed to create custom functions, but that doesn't mean that you won't. I would like to point out, though, that it will benefit you greatly to treat custom functions in a very generic manner. If the functionality you're needing is very specific to a problem, it might be best to create a one-off computed as opposed to a custom function that will be available to all instances of that type. To start, add a new JavaScript file named custom-function-ViewModel.js to the ViewModels folder in our project, and insert our boilerplate code for the revealing module pattern. Then add a new HTML page named custom-function.html and add all of the script references, style sheet, and code to satisfy the MVVM pattern as in previous examples. Now add a new JavaScript file to the scripts folder named knockoutextensions.js. We'll use this file to add all of our custom functions, extenders, and bindings throughout this section. We want to use this function with all of our observable arrays, so we'll add it to the fn object. When we use this function, we'll pass the name of the property and the value by which we're filtering, so that will be our argument list for this function. Our custom function will return a filtered array, but we want that array to automatically update whenever the source array changes. To accomplish this, we'll return a pure computed so that we get any updates of the source array. We'll also pass in the this object as our context because this refers to our observable array. Within the pure computed, we'll iterate through our source array and return a local array of items that have a property and value that match our criteria. To implement this function, switch to our custom function view model and add a public property for our catalog. Then create an init function that gets our catalog from our data context. Next, add public properties for each of our media types. We'll define them as undefined and then make our assignments in the init function. In the init function, assign to each of our media type properties a call to our custom function, which is now available from our catalog property. We'll pass media type as our first parameter, which is for our property name on which we're filtering. Then we'll pass the value on which we're filtering as the second parameter. In our view, we'll display the same table for each of our arrays, so this is a perfect scenario to use a template. Insert virtual elements for each of our media type arrays and a template to render the output. The result is each media type array filtered by property and value and rendered in their own separate tables. Custom functions are pretty simple to create and use. As I mentioned, I haven't found many circumstances where I've needed to create custom functions, but it's definitely an option to keep filed away in the back of your mind. In the next video, we'll learn how to create custom extenders. Hello again! In the last video, we learned how to enhance Knockout's core data types by creating custom functions. In this video, we're going to look at how to add extensions to observables by creating some validation extenders. There are plugins available for Knockout.JS that perform validation, but if you like creating and controlling your own, extenders are a great way to implement validation. Knockout's extenders provide a way to attach custom properties to your observables. These properties likely aren't going to be sent back to the server for processing, but instead would be used to augment an observable with additional metadata that can be used for other tasks. To demonstrate, we're going to add validation to our borrower view using extenders. Create a new view model named ExtenderViewModel.js and a new view named Extender.html. Set up these files just like we have done in previous examples. We're going to mimic the functionality of the Manage Borrowers page we created in the last section, so to speed things along, copy over the code from BorrowerViewModel.js and Borrowers.html. Now switch to the KnockoutExtensions.js file and we'll add our extenders. Creating extenders is as simple as adding functions to the ko.extenders object. We're going to add an extender named required. The first argument of the function must be the observable you're extending, and the second parameter is any options for the extender. You can either return the observable, that would be the target object in our example, or you can return a different object like a computed, which uses the original observable. We want to add some properties to our observable to help us ascertain the validity of our value. Let's add a hasError property and a validation message property. We can use Knockout's subscription functionality to re-evaluate our observable when a change occurs, so let's create a function to which we can subscribe. In this function, we'll determine if the new value is null or undefined and assign a value of true or false based on that evaluation to our hasError property. For the validation message property, we'll perform a similar evaluation and assign an appropriate message. Next, we'll call the validate function so that the observable's value is evaluated when the binding occurs. Then we'll subscribe to the function to catch any future changes. To use the extender, open borrower.js in the Models folder and add Knockout's extend method to the name and email observables. The observable itself is passed to our extender implicitly as the target argument of our function. To use our extender, pass an object literal to the extend method with a property named for our extender, in our case required, and a value which is the options argument of our extender, in our case the message. Let's also add a pure computed property named hasError and update its value based on whether or not any of our required properties has an error. Now switch to our view and use the CSS binding to add a CSS class named error if the observable has an error. The CSS for this simply places a red border around the element. When we look at this in the browser, we see that the input element's border turns red when we delete its contents. To polish off our validation, let's disallow saving when there's an error. Switch to the view model and check the object's hasError pure computed property to determine if there's an error before saving the object. You can use this pattern in other scenarios. I have included a validDate extender as an example of how to validate dates. You can also apply multiple extenders to the same observable simply by adding additional properties named for your extenders to the object literal you pass to Knockout's extend method, like we did in our borrower.js model. There is a lot that you can do with extenders, and I've included a few more examples in the sample code for this section, which is available on Pact's website. Of particular interest is an extender for observable arrays that creates additional properties to paginate the data. Extenders are a very powerful tool, but, like custom functions, they should be written in a very generic manner so that you can get the maximum amount of reuse from them. In the next video, we'll examine custom bindings and how we can use them to interact with jQuery widgets. Greetings! In the last video, we saw how to use extenders to add functionality to observables. In this video, we're going to take a look at one of the best and most powerful extensibility features in Knockout.JS, custom bindings. We've already used many of Knockout's built-in bindings like text, for each, and template, but we can actually create our own bindings. We're going to demonstrate this by creating a dialog binding that will allow us to bind an observable to a jQuery dialog. With this custom binding and several others I've included in the sample project for this section, we have all the components we need to finish the Knockout Media Sample project. Before we begin, you will need to download jQuery UI and install it in your project. Be sure to install both the JavaScript files as well as the CSS files. You may want to reference the sample code for this section, available from Pact's website, to see how I set up the scripts in CSS. Let's start by adding our new binding to the knockoutextensions.js file. Custom bindings are added to the KO binding handlers object. The object you add to the binding handlers object can have one or both of these properties, init and update. The init property is a function that is called as soon as the binding is applied to its DOM element. You can use this to set up the initial state of the DOM element and register any event handler. The update property is a function that is also applied when the binding is first applied, as well as when any dependent observables change. Most commonly, the argument list for these functions will contain a reference to the DOM element being bound, the data item bound to the element, and an object literal that contains all of the values bound to the element. To initialize the DOM element to which we're binding, we'll call the jQuery dialog method on our element. There's a timing issue when doing this as soon as the element is bound, however. When jQuery creates a dialog, it appends it to the end of the DOM document. The problem is that Knockout tries to data bind it again when it reaches the bottom of the document. To work around this, we can place the call to dialog in a set timeout, which is not executed until the page is fully parsed. jQuery's dialog method accepts an object literal that serves as options for the dialog. To accommodate this, we can use the allBindings accessor to get an optional object literal where we can specify the options. The last thing we want to make sure we do is properly destroy the jQuery dialog when the element is disposed. If we don't, it'll cause a memory leak. Knockout provides a utility method that allows us to create a callback method whenever the element is disposed. Within that callback, we can ask jQuery to destroy the dialog when the element is removed from the DOM. For the update, when we data bind an observable to the dialog, we want to open and close the dialog as the observable changes from false, null, or undefined to an actual value. To accomplish this, we can get the value from the value accessor parameter and evaluate it. Since we can't know for sure if the value being bound is an observable, we can use Knockout's unwrap method to return a value regardless of whether it's an observable or a plain object. We also need to check if the element is in fact a jQuery dialog and has been initialized properly. Once that's done, we can open the dialog based on whether the bound value is true or non-null defined object. To implement our new dialog binding, let's update our media.html view and get it ready for the dialog. Remove the ISBN table column and add a new column with a button. We'll add a new method to our view model called edit to handle opening and closing the dialog in a few moments. Then, change the other columns to just display the data using the text binding. Also, Add a script reference to jQuery UI, as well as an import in the site.css file for the all.css file you downloaded from the jQuery UI website. In our view model, add a new public property named Media and make it an observable. Then add a public function called Edit. When the button in the table is clicked, it will pass the table row's media object and the JavaScript event object to this method. We'll simply assign the object to our media property, which we will use to trigger the opening of our dialog. To implement the dialog binding, create a div element and insert a template binding. We could use a with binding here and assign our media property, but we're going to reuse the form we're about to create, so a template is more appropriate. We also want to use an if binding here because we don't want the form in the template to bind until the media property has an actual value. Here's where we use the dialog binding we created. We simply assign the media property to it, and the binding takes care of initializing this div as a jQuery dialog. We'll add some property options to the dialog too. We can give the dialog a title, buttons, a CSS class to hide the default close dialog button, and specify other options to make our dialog functional and presentable. The template is simply a form for our media object's properties and uses the same strategies we employed in previous videos to create a data entry form. Since we're saving media objects one at a time with the dialog, we need to change our save method. So let's rename it to save edit. After saving the media property using our data context, set its value to undefined. This will cause our dialog to close. To wrap up our UI, we'll remove the old Save button and make sure we have added Knockout.JS to our script references. When we look at the page in a browser, we'll see a jQuery dialog appear when we click the Edit button. Any values we change are reflected in the table, and when we click the Save button, the values are persisted to our local storage. Now let's add some validation to the UI. We'll use the required extender on the name and media type observables in the model. Then we'll update the template to make the labels and form fields turn red when there's an error. You can find the CSS for this in the sample code for this section, which is available on Pact's website. We can also check the media object has error computed and only save the object if there's not an error. That takes care of editing the existing items, but what about adding new ones? Well, we can use the same template since it has all of the required fields to create a new media object. The problem, though, is that we need a way to cancel the dialog if the user changes their mind when creating a new media item. The reason I hid the default close dialog button and didn't include a cancel button on the edit dialog is because we don't yet have a way to undo changes to objects. There are ways to accomplish this, but it's a little beyond the scope of this course. So instead, we'll avoid the issue altogether and treat edits and adding new items as totally separate activities while sharing as much code as we can. Switch to our view model and add a new public observable named New Media, as well as public methods called Add, Cancel, and Save New. The Add method simply adds a new media object to the new media observable. We'll use this to trigger the new media dialog. The Cancel method assigns undefined to the new media observable, which will cause the dialog to close. And the Save New method will check for errors, save the new media object, add it to the catalog observable array, and then set the new media object to undefined to close the dialog. Now switch to the view and add a button above the table to call the Add method. Next, insert a div element and set up a template binding and dialog binding like the Edit dialog, but change the bound object to be the new media observable and add a cancel button to the dialog options. Now when we click the Add New Media Item button, we'll see a dialog with our form fields as well as a Save and Cancel button. Clicking Save will add the new media item to local storage and to the catalog observable array, which will then render it in the UI. The other two views in our project for managing media items and borrowers can use the same pattern for creating jQuery dialogs. In addition to jQuery dialogs, I have included jQuery-related bindings for buttons and date pickers in the Knockout.Extensions.js file. You can see their implementation in the code for this section, which again is downloadable from Pact's website. I also included examples of binding handlers that set up form fields that tab to the next available element when the Enter key is pressed, as well as a custom binding that clears an input element when it receives focus. I hope that this section was enlightening for you. As we learned, there are many ways to extend and customize Knockout.JS to fit your needs, including custom functions, extenders, and custom bindings. In the next section, we'll take a brief tour of some advanced topics in Knockout.JS. Welcome back to learning Knockout.JS. In our last section, we saw how to implement custom bindings, custom functions, and extenders. In this section, we're going to preview some of the advanced things you can do with Knockout.JS. We'll create and consume a Knockout component as well as a custom element. Then we'll explore Require.js and how it can help us to load external templates and components. And lastly, we'll take a peek at Durandal and how it's used to create single-page applications. In this video, we're going to create a Knockout component and see how easy it is to consolidate a view and view model into one unit. Then we'll look at how to implement that component as a custom element. Let's start by adding a new view and view model to our project. I'll name them component.html and component-viewModel.js. Now add a new folder to your project called Components, along with a new JavaScript file called colorlist.js. A Knockout component combines a view model and a view into one unit. To use it, we need to register it to Knockout's components object. The component is given a name and defined with an object literal that contains two properties, viewModel and template. The view for this component will display an unordered list of colors, so we'll define what we need in our view model to support that. We'll also add a method to show a JavaScript alert when a color in the list is clicked, so we'll add a function for that too. The viewModel definition has an optional params argument that we will use to pass in a function from our containing view and view model. That way, we don't have to define problem-specific functionality in our component, but rather leave that up to the containing view. In our component-viewModel.js module, we'll add our method for showing the selected color. In our view, we'll use Knockout's component binding to name the component we want to use as well as the parameters we want to pass to the component. In this case, we're assigning the showColor function to the component's display function. Here's how it looks in the browser. Now let's use Knockout's custom element feature to render our component. There really isn't anything more to do to the component or view model. The custom element feature is built into the component. Switch to the view and use the component name as the tag name of a new element. You can optionally add a params attribute to pass any parameters to the component. These parameters can be observables, callback functions, or any simple values that are needed in the component. As you can see, the functionality is the same. In the next video, we're going to look at Require.js as a way to load templates and components. Salutations! In the last video, we saw how to create and use components and custom elements. In this video, we're going to look at Require.js, an asynchronous module definition loader, and how we can use it to dynamically load a template for the component we created in the last video. We've done a lot throughout this video course to make our projects more modular. As we've seen, module-based coding eases maintenance and increases reusability. However, managing dependencies between modules and dynamically loading dependencies, whether scripts or components, is not always easy. Require.js provides a library to help manage dependencies between modules. To start, download Require.js as well as the text plugin from their website and place the files in your scripts folder. If you're using NuGet in Visual Studio, there's a package for Require.js that you can install instead. Next, add a new HTML page to the root of the project named require.html, as well as a JavaScript file to the ViewModels folder named require-viewModel.js. Don't set them up in the same way we have done before, however. We'll use the conventions needed by Require.js to define and reference these files. Now add another file to the scripts folder named main.js. This will serve as an entry point for our application. Then add a file to the components folder named colorlistrequire.js. We'll use this file to define our component in a Require.js friendly way. Lastly, add a new folder named Templates with an HTML file named colorlist.html. Switch to main.js and add a call to require. The first parameter is an array of dependencies we will need for this module. We'll add entries for Knockout.JS as well as our view model. The second parameter is a callback that accepts references to our dependencies which we can use to start our application. In the function, we'll register our component, but this time we'll use require to load our component file dynamically. Then we'll call apply bindings on the dependency for our view model. Require ViewModel.js is similar to what we've done throughout this course, but it's wrapped in and returned from a require.js define method. Like the require function, define uses the first parameter to specify an array of dependencies and the second parameter as a callback to execute actions using those dependencies. We can still use the revealing module pattern, but the overall syntax is a little different than what we're used to at this point. We'll use define to create our component too. Switch to colorlist.require.js and insert a call to define. We'll add dependencies for Knockout as well as our template, but for the template, we'll use the text plugin to let require know that we're retrieving HTML and not a script that needs to be executed. Our colorlist.html template is the same as the template we used in the last video on components, only now it's external to the component. Our view, require.html, only needs one script reference for require.js. That reference uses a custom data attribute named data_main to specify the entry point of our application, in this case, main.js. We need only reference it by name, though including the extension works too. When we execute this page, main.js is called, which loads Knockout.js and our view model. The component is registered and the template file is loaded too. Then apply bindings is called and our page is data-bound. It takes a little more work and a slightly different style of programming to get require.js and Knockout.js working together, but as you can see, the advantages are more modularity and less code to reference dependent scripts and templates. In our next video, we'll look at Durandal, a framework that combines Knockout.js and require.js as a means to create single-page applications. Welcome back. In the last video, we saw how to combine Knockout.js and require.js to give the ability to dynamically download dependencies such as script files and templates. In this video, we're going to take a peek at Durandal, which is a JavaScript framework for building single-page applications. Durandal is a framework, whereas Knockout.js and require.js are script libraries. Durandal is an end-to-end, all-inclusive code base. It covers eventing, navigation, modals, message boxes, state management, and bundling and optimization. It's built on top of Knockout.js, require.js, and jQuery, so you get all those libraries in one framework. If you haven't already, download the project for Section 7 from Pact's website. We'll go through the pages in the sample, but Durandal is large enough to warrant its own video course, so we won't go into it very deeply. We'll start with Durandal.html. It's much like the page we used in the last video. There's a script reference to require.js, and we have an entry point specified in the data_main attribute. What's different here, though, is that our content is a single div element with an ID attribute value of application host. Durandal actually loads your views into this div. When you browse from page to page in your application, Durandal replaces the content of this div with each new page's view. So when we say Durandal supports building single-page applications, there is literally only one HTML page in the entire application. The entry point JavaScript file, in this case init.js, takes care of configuring Durandal and setting up script paths and dependencies for the application. In app.start, there's a call to app.setRoot, which sets the default view model to use when the application starts. There's also a call to the view locator's useConvention method, which, by default, looks for views in a folder named Views in a relative path to the view model, so that you don't have to specify their location. Our home.js view model is set up a little differently than the last video, but the overall structure should look familiar to you. And our view is simply the markup we want Durandal to inject into its application host container. Note that Durandal uses convention over configuration in that the view should be named home.html so that it gets paired with home.js. This makes development in Durandal more intuitive and simpler to maintain as long as you stick to the naming convention. When we execute the page, Durandal takes care of loading all of our dependencies and data binds our view to our view model. I hope that you got a sense of where to go next on your Knockout adventures. Admittedly, Require.js and Durandal can complicate your projects and development process, but for larger applications, the trade-off for better organization and more modularity might be worth it to you. There's a learning curve to overcome, but now that you've got all of Knockout's basics firmly in hand, I know you're ready to take it to the next step. I want to thank you for watching this video course on Knockout.js. This was my first attempt at creating a course like this, so it's been a learning process for both of us, but I have thoroughly enjoyed taking you on this journey. If you have any questions, please feel free to email me at robert.gott@outlook.com. And be sure to check out Packt Publishing's other great offerings on JavaScript, Knockout.js, and jQuery.